Hi, I'm Glenn Woppman, CEO of ASSET InterTech. Yeah, let me talk a little bit more about the embedded instrumentation market and some trends. So if you look at the test and measurement market, traditionally, of course, there's been oscilloscopes and logic analyzers and signal generators and so forth. And the big suppliers of that we all know are Tektronix, Agilent, and so forth. And then in the mid-'80s is when National Instruments started marketing and educating the market on the virtual instrument concept. And at the end of the day, it was basically PXI technologies, boards, instruments as individual modules in a box, and LabVIEW as a graphical programming system. And so what ASSET's focused on is embedded instrumentations, and so it's sort of analogous to the virtual instrumentation. ScanWorks is analogous to LabVIEW. It's the software tool that's controlling the embedded instruments, and instead of the instruments being a box or a board, they're actually IP inside semiconductors. And as we see the explosions of SoC devices and billions of transistors on a chip, now there's not a problem with putting embedded instruments inside chips. There's plenty of room, and in fact now it's compelling because there's so much functionality in the chip that the engineers need different instruments built into the chip to help them make sure that the chip's working, the board's working, the software's working with the chip, and the whole story. That's really a key piece because the embedded software is a critical component to make the whole board work, the whole system work, and so forth for the customer. Let me also delve a little bit more into the technology of embedded instruments and kind of the trends and history. I think history always teaches us good lessons. So embedded instrumentation actually started with the technology of software debug, moving from what used to be a hardware box with a target cable into silicon, and it has all these different acronym names. So Intel's ITP, Motorola Freescale was BDM. When I was at TI DSP was MPSD. So we have the alphabet soup of acronyms, but in essence, they've embedded scan technologies within the silicon to enable access to registers, to enable the software guy to run software and debug his code that is going to tell the processor what to do and perform its function. So we really began with embedded instruments in the software debug world, and then we moved quickly to the manufacturing test world. Because of packaging, we lost access. Thus, we had boundary scan. Then we leveraged the processor as a functional instrument. So we kind of look at the processor as the smartest instrument on the board because it can talk to everything. And then the next was, once we got above 5 gigabits per second, we moved from parallel to serial buses, and once we have PCI Express 2s and 3s and SATAs and QPIs and all of that, above 5 gigahertz per second, everybody started putting IP, inside of those buses so that we could do kind of traditional oscilloscope functions like eye diagrams, traditional BERT functions like bit error rate measurements and so forth. And then now the next turn is IJTAG, to give us an infrastructure to put inside an SoC so that we can access all these different instruments for a very complex SoC debug. So, and that sort of addresses putting more of the test technology inside the chip so the chip can test itself, because the capital equipment cost for IC testers is very expensive, as we all know. So how we looked at it is, there's 4 different things. There's one, the software debug emulation, the manufacturing test access, the access going away on high-speed buses, so you need to put IP to validate those buses inside silicon so you see what the silicon sees, and of course the IC test challenge of putting more and more IP inside ICs to drive the cost of test for semiconductor guys down. So if you look at that portfolio and that picture, that is what today is kind of the final key piece that we've put together. And so we're unique, as I think the only, that I know of, the only company in the world that has this portfolio of technologies, and even more important, it's the portfolios of engineering talent that we have that is looking at these problems from all these different angles and not in silos. And I've been in a semiconductor company, and so I kind of understand, that you'll look at a problem one way, but boy, if you can have, someone come from another angle, you got a much better chance of solving the problem. And part of that angle is, of course, you, our customers, who are going to give us feedback and so forth. But we can have much more in-depth cross-functional team discussions than we ever could before. So that's really exciting. So it's, that's the technology story, but the technology story to, coming to the customer, we're just thrilled about.